atoms are very, very small. So instead of talking about singular or atoms, we talk about these in larger quantities. And for the chemist, the mole is a chemical counting unit that we use when we're talking about really small things like atoms. First of all, we might think, though, what is a counting unit, and something that you're familiar with? A counting unit could be something like 1 dozen. And if I say 1 dozen, you would tell me that it has 12 units. And if I had a dozen donuts, you would know that I had 12. Or maybe I sell shoes, and I sell them in pairs. And so if I said I had a pair of something, you would know that I had 2 units. Those are counting units. And depending on your profession or your hobby, there may be words you use to associate with a number. Well, for chemists, the mole is a counting unit. Now, because atoms are and molecules and ions, all of those things are so small, our unit isn't something as common as 12 or 2. The number associated with it is 6.02 times 10 to the 23rd. And that is rounded to 3 significant figures. The mole is defined and is based on the number of carbon atoms, and it's how many carbon atoms are exactly in 12 grams of the carbon-12 isotope. So that's how they came up with this number. And it was Avogadro, who was an Italian scientist, who first proposed the concept of a mole in the 19th century. So he kind of gets a shout out when we're talking about the mole, because we call it Avogadro's number. Now let me just give you an idea about how giant this number is. If I had aspirin, and an aspirin molecule is acetylsalicylic acid, and if I had 1 mole of aspirin, so 1 mole of aspirin would weigh about 180 grams, around that. Now, 180 grams is not that much if you think about your experiences in lab. The balances we have in lab could measure 180 grams, and you could get a normal-sized beaker, and it might fill it up a little bit. So that is an aspirin molecule. Okay, that would be 1 mole of aspirin molecules. Well, what if I had aspirin tablets? Well, I recently read in the textbook I was reading through, and this amazes me, I'm pretty impressed by this, that if I took aspirin tablets and I had 1 mole of them, if I laid them side by side, they would cover a football field. So lay them on a football field, and I'm not even close to having a mole of them. Then I start stacking them. And if I stacked those aspirin tablets till I counted up to 1 mole, I would have, how many is this? 20 billion miles high of aspirin before I got to 1 mole of aspirin tablets. Now think of how small an aspirin tablet is, and imagine me laying it out on a football field. I lay them side by side, and then in order to count up to 6.02 times 10 to the 23rd, it has to go 20 billion miles into the sky. That's a lot of aspirin tablets. That is how big 1 mole is. And I emphasize that because we don't use a mole in our everyday life. This really is something that chemists use a lot, because atoms and molecules and ions are so small, we have to have a lot of them before we can start measuring them on our balances and doing things in lab. So I just want to impress you that this is a gigantic, gigantic number. Now, how are we going to use it in our calculations? So moles, and I call these, I have 2 tools that I think about in this chapter, and this is the first one, is Avogadro's number. And what Avogadro's number helps us do is go between units of moles and units of molecules, atoms, and ions. So things that are really, really small. So see here, I'm going to use Avogadro's number. Now remember, in conversions, to do a conversion, we like to set up a ratio. Well, here's my ratio. I have the particles on the top, and particles could be written as atoms, molecules, or ions, and then I have 1 mole on the bottom. Remember, on the previous page I had written this as an equality, and we know that equalities we can use as conversion factors. So here I have a couple different problems, and let's try to set them up. So the first problem is a question, and it gives us the number of moles, and it wants us to go to molecules. So, like a conversion problem, I would take what I was given, 2.5 moles, and if I'm using Avogadro's number up here, I would want the moles to be on the bottom so that they cancel. And the 6.02 times 10 to the 23rd to be on the numerator. And we're doing molecules, so I can, instead of particles, I'll write in molecules. And so what I would be doing is I would be taking the 2.5 moles and multiplying it by the number of molecules. And to two significant figures, because that's what I was given, I get 1.5 times 10 to the 24th of molecules. Now, something interesting here, in the problem it tells me in letter A it's 2.5 moles of penicillin. But notice it didn't matter if it was penicillin. The only thing that really impacted this was that I had 2.5 moles. So the next one gives me 0.4 moles of sugar molecules. So I know I have 0.4 moles. If I'm going to use Avogadro's number, I'm going to put the moles on the 1 mole on the bottom, and the 6.02 times 10 to the 23rd molecules on the top, the numerator. Whoops, molecules. Remember, molecules and moles are not the same thing. And so I get 0.4 times 6.02 times 10 to the 23rd, and I get to two significant figures, 2.4 times 10 to the 23rd molecules. So again, notice it really didn't matter that it was sugar. If I took the number of moles, I just used Avogadro's number to figure out molecules. So in this first step, to go from I went from moles over to molecules. What did I do? I multiplied. So to go from the number of moles over to the number of molecules, you will multiply by Avogadro's number. Well, now let's look at the next problem. And in this case, they've given us molecules, and they want us to figure out the number of moles. So in this problem, we're going to go from molecules, which they've given us here, and we're going to figure out the number of moles. So again, we write the number here, 6.02 times 10 to the 25th molecules. Now looking up at Avogadro's number up here, I see that the 6.02 goes with the number molecules, and so in this case I'm going to need to divide by the 6.02 times 10 to the 23rd molecules so that my units cancel. And I will put the 1 mole on the top. Now for some of you, how you entered in your calculator, I need you to put parentheses around the bottom. So if you don't get the correct answer, I want you to try again. Make sure you're putting in your parentheses. And I get the number 100. So this, my letter A would have 100 moles. So 6.02 times 10 to the 23rd molecules would end up being 100 moles. Now I don't even know, I didn't write the whole problem down in this example, so I don't even know what it is. It could be sugar, it could be salt, it could be penicillin, it could be anything, but Avogadro's number, you don't have to know exactly what it is. And now the second one, and unfortunately I didn't, when I designed the notes, I'm going to bring it up here, okay, sorry. And this is 3.01 times 10 to the 22nd molecules. And again, since I was given molecules, I'm going to have to put the 6.02 times 10 to the 23rd 1/3 molecules on the bottom and the 1 mole on the top. And remember, you might have to put parentheses. So 3.01 times 10 to the 22nd divided by 6.02 times 10 to the 23rd gives me 0.05 moles. Now, if I wanted 3 significant figures, the numbers in the front are not significant, so I'd have to add, it must be a stop at 5, so I'd have to add zeros if I wanted to do that. So there's the answer for the second one. So a summary of that then, notice on the second one, if I was given molecules on this side and I wanted to go back to moles, I divided. So to summarize, if I have moles and I want to go over to molecules, I'm going to multiply by Avogadro's number. I can use my units to help me figure out that. If I have molecules and I want to go back to moles, I divide by Avogadro's number. And now that's going to give me to go between moles and molecules. Now this doesn't really help me out in lab so much. So it does help me know how many molecules are there. But in lab we need to go to grams. And in the next tool we use, molar mass, we're going to learn about grams.